So let me give you a little test here based on what we've just talked about. What do you think? So I want to see how you would answer this question. And hopefully, again, what we just talked about is fresh in your mind and you'll know what the answer should be. So you conduct a hypothesis test with a significance level of 0.05. You obtain a p-value of 0.35. What should your decision be? So I'll give you a moment to reflect on this, think about it. You might be looking at this and maybe you're thinking D is a good answer. Maybe you're thinking, I don't really see a lot of differences between A, B, and C. They all seem to be saying the same thing to me. So I can see why you might want to go there, but I'll tell you right away that D is not the answer. And I'm hoping that some of what we've talked about is coming to mind and helping you here. You're remembering a few little things that I mentioned here and maybe in earlier videos. Now, A is not a good choice because of that word accept. So we never want you to say that you accept the null hypothesis. If you get a large p-value, saying that you accept the null might lead some to believe that you think the null is true, or that you're concluding that the null is true. And we don't want to conclude that. We assume it's true when we start our hypothesis test, but we don't want to conclude definitively that yes, it must be true because we got a large p-value. And sometimes saying that word accept might lead others to think that you're saying that the null is true. So we don't want to accept the null. You might also remember that we don't state our results in terms of the alternative. So when you conduct a hypothesis test, we always want you to go back to that null. You're either going to reject the null or you're going to fail to reject. So here we know we're going to fail to reject because we have a p-value that's larger than alpha. So part of the reason I wanted to show this is just to remind you that we state our conclusions in terms of the null, and also to remind you that it's really important how you state those conclusions. Some have told me that when they take statistics, they feel like they're taking a foreign language because there are so many rules in terms of what you say and how you say it. And here, I'm going to be kind of a stickler for this, but it's really important how you state your conclusions when you conduct a hypothesis test. You're either going to reject the null or you're going to fail to reject it. And if you don't like saying fail to reject, you could say you do not reject. You either reject or you do not reject. But you never say you accept. You never say you believe the null is true, or that you're concluding it's true, or that you're concluding it's false. Okay, so enough of that. Let's jump into another example where we actually conduct another test. So I'll tell you right off the bat here, this is a question about means. So it's claimed that the average American receives a tax refund of $3,120. So notice here we're automatically starting with a quantity or an amount of something. So that's a good clue that we're going to be dealing with means. You believe this claimed value is too high. That's a clue as to what your alternative hypothesis should be. You gather data from a random sample of 50 taxpayers. M equals 50. And it's observed that this sample has an average, so we're giving you a sample average of 2850. So x bar equals 2850. Mu equals 3120. And a standard deviation of 645, so S equals 645. Now let's conduct our hypothesis test, and we'll assume that alpha is 0.05. Okay, so lots of good information here that we can use to figure this out. So again, mu equals 3120. We begin with the claimed population parameter. We think that value is too high, meaning we think the actual value is less than that. So mu is less than 3120. And notice, it would probably be better to write these in terms of dollars, since that's the unit we have here, but it's certainly okay to leave that out. So Z equals x bar minus mu all over s divided by the square root of n. So when I plug everything into this formula, and again, I might leave a little bit out of 2850 minus 3120. Oops, sorry about that. Okay, so I'm going to end up getting, and again, I rounded a little bit along the way, but I ended up getting approximately negative 3.0. And again, if rounding can help you save a little time, please do it. What's going to be really important is that you show your work. If we don't want you to round, generally we'll tell you not to round, or if we want you to round in a specific way, we'll try to be specific about that in the problem. We'll try to give you those clues so you know. But if we don't tell you, then round to maybe 1 or 2 decimal places, just to make the calculations easier. I got negative 3.0. I'm going to go to table B now, and I'm going to end up with a p-value of 0.0013. I'm hoping it makes sense how I got that based on what my test statistic is, but if it's not making sense where that number is coming from, let me know. So this is my final answer that's in the form of a probability. Here I'm going to reject the null hypothesis. And again, it's going to be because our p-value is less than alpha. So here we have some evidence against the claim that the average American receives a tax refund of $3,120. So again, here was a nice example where we're going through a one-sided or one-tailed hypothesis test. Here we're working with means. In our Thanksgiving pie example, we were working with proportions. Okay, let's try another example here. This is kind of a fun one. A study came out not really that long ago, and it was all about how we see the letter G all the time in print, but do we really pay attention to what it looks like? So up here is how the letter G is often printed if you're looking at a computer, if you're reading something on the computer. And these researchers believe that even though we see that all the time when we're reading, because we do a lot of reading online, we wouldn't really recognize that letter out of context. So if we were given a lineup with several G's and this particular G was in that lineup, it would be hard for us to recognize it because we just don't pay careful enough attention to what we're reading. So I'm hoping that makes sense. So these researchers did a study. They gave individuals this particular array of G's. And they asked them, which of these is the way G is typically printed when you're reading on a computer. So they had the option of choosing 1, 2, 3, or 4. Now I want you to think of this as a hypothesis test. So let's say we give this lineup to many people, we ask them to choose the correct option. The null hypothesis would be that people are just guessing, that they have no idea which one is correct. They have 4 options here, they're just going to choose any one. And again, the null is always that nothing's going on, that any results we see are just because of chance. So in symbols, what would that look like? And you might think back here to that example that we had in chapter 22, where I showed you those pictures of Tim and Bob. And I asked you to try to think about which of those men was Tim. If people are just guessing and they're not using facial cues and trying to match those to names, then they have a 50-50 chance of choosing either man as being Tim. So if they're just guessing, nothing's going on, it's just like they're flipping a coin. This is the same type of situation. You're just guessing. Any one of these is equally likely to be chosen if you're just guessing. So the null is that in the population, if people are just guessing, about 25% of them, or 0.25, would choose the correct option. So again, hopefully you see that we're getting 0.25 just by dividing 1 by 4. So there's a 1/4 chance they'd choose any of these, if there's nothing going on. Okay, now you think that people are not just guessing. when they're given that array of G's, but you're not sure if they're going to do better or worse than just guessing. You just think they're going to do differently than just guessing. So this means our alternative hypothesis would be what? In this case, we would have P does not equal 0.25. So you don't know if they're going to do better or worse. You just think they're going to do differently. That's a cue that you should be doing a two-tailed test. Let's say now that you give this lineup to 100 individuals, a random sample of 100, 23 of them choose the correct answer. So what would our test statistic be? So remember that P, our claimed population, proportions 0.25. P hat would be 23 over 100, or 0.23, and then N is going to be 100. So this again is just getting you to think about how you'd figure out the test statistic. What does it mean when we ask you to find a test statistic? That means we want you to figure out the z-value. So P hat minus P divided by our denominator here. So 0.23 minus 0.25. Okay, so I got approximately negative 0.5. My p-value, so if I get a z of negative 0.5 and I'm doing a two-tailed test, what do you think the p-value is going to be? So I want you to pause and try to figure this out on your own. Come back and see if you got what I got. So the p-value is 0.6170. So if you're not sure how I got that, let me know, but hopefully it's making sense where that number's coming from. And obviously, if we're assuming an alpha level of 0.05, we are going to fail to reject. So I know this one was a little bit more, maybe a little bit more of a complicated example, just because it might not, we weren't actually given a number within the question to plug into our null and alternative hypothesis. We had to think conceptually about what the null should be and what the alternative should be. But I hope now that you see this, it's starting to make a little bit more sense. Again, if not, let me know and I can try to break this down in another way or explain it in a different way. And if anybody's really interested in actually reading the study, so again, this was an actual study. There's a link here where you can go and read more of the details of the actual research. So we're going to pause here, and we have probably a couple more videos to get through just because I want to do a lot more practice, and I also wanted to elaborate a bit on some terms that are coming up in chapter 23. Okay, so I'll be right back.